Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a vector algebra problem using properties of dot product. As per the problem, let vector u, comma vector v and vector w be such that magnitude of vector u is equal to 1, magnitude of vector v is equal to 2, and magnitude of vector w is equal to 3. If the projection of vector v along vector u is equal to that of vector w along vector u and vector v is perpendicular to vector w, then the magnitude of vector u minus vector v plus vector w is equal to, we are given four answer choices. We have to choose the correct answer choice. Let's start by analyzing the given information. We are given the magnitude of the three vectors. We are also given that the projection of vector v along u is equal to projection of vector w along vector u. We can use the formula for scalar projection. So as per this information, vector v dot vector u over magnitude of vector u is equal to vector w dot vector u over magnitude of vector u. We can simplify this equation by cancelling out magnitude of vector u from the denominator on both sides. I get vector v dot vector u equals vector w dot vector u. We are also given that vectors v and w are perpendicular to each other. That means their dot product is equal to 0. We have to find the magnitude of vector u minus vector v plus vector w. We can find it using a property of dot product. As per the property of dot product, the square of magnitude of this vector expression is equal to the dot product of u minus v plus w by itself. We can write it as we can simplify the dot product expression on the right side by distributing the vectors. I get vector u dot vector u. Next we get minus vector u dot vector v. Next we get vector u dot vector w. Next we distribute minus vector v. I get minus vector v dot vector u, then plus vector v dot vector v. Next we get minus vector v dot vector w. Next we distribute vector w. I get vector w dot vector u. Next we get minus vector w dot vector v. And lastly we get vector w dot vector w. Now we can simplify this expression. As per the dot product property, vector u dot vector u is equal to square of magnitude of vector u. Vector u dot vector v can also be written as vector v dot vector u. Vector u dot vector w can also be written as vector w dot vector u. Vector v dot vector v is equal to square of magnitude of vector v. Vector v dot vector w is equal to 0 because they are perpendicular to each other. Vector w dot vector v is equal to vector v dot vector w, and vector w dot vector w is equal to square of magnitude of vector w. We are given that the magnitude of vector u is 1. We can combine the terms minus vector v dot vector u and minus vector v dot vector u. I get minus 2 times vector v dot vector u. Next, we can combine the terms vector w dot vector u and vector w dot vector u. I get 2 times vector w dot vector u. The magnitude of vector v is given as 2. Vector v dot vector w is equal to 0, so that term goes away. And the magnitude of vector w is given as 3. Now we can simplify the terms. 1 square is equal to 1. As we found out earlier, vector v dot vector u is equal to vector w dot vector u. So we can replace vector v dot vector u with vector w dot vector u. We found it from the scalar projection equation. 2 square is equal to 4. 3 square is equal to 9. We can cancel out the terms negative 2 vector w dot vector u and plus 2 vector w dot vector u. So we are left with 1 plus 4 plus 9 is equal to 14. We can find the magnitude of vector u minus vector v plus vector w by applying square root to both sides. On the left side, the square root and the square will cancel each other out. So I get magnitude of vector u minus vector v plus vector w is equal to square root of 14. So the answer should be option C. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.